So what you're looking at here is a banking balance sheet. This is exactly the same style of question that we've done the last several days. Of course, the difference is instead of being in the form of a short answer question like this, which includes everything that you see in this, instead of this, they're giving us what's called a banking balance sheet. And so that's the first thing to know here. This balance sheet is one way that AP likes to present banking questions, and it's just different. And so we need to learn how to read it. Our starting point then is to remember that assets and liabilities are how we divide this. And so a T-chart is broken into two halves. On the left side, we have assets. This is what the bank owns. And on the right-hand side, we have liabilities and equity. This is what the bank owes. That's always our starting point to make sure we understand our vocabulary. Then what the bank shows us is that they have reserves and loans. Now, if you recall, reserves are literally cash on site that the bank has. Loans, this money is already lent, and these are contracts, in fact. And so, ladies and gentlemen, that means that we can pretty much ignore this, the entire problem. This is locked in contracts. The bank can't change that. They put it there to confuse you. On this side, we see demand deposits. These are checking accounts. The bank owes checking accounts because it's mine, not theirs. I have my money in the bank. I can show up and get my money out on demand. That's why checking accounts are called demand deposits, because I can withdraw the money upon demand, including writing checks and using an ATM card. Equity or net worth is what the owner is owed. It's what the owner is owed. And so remember, every bank is owned by a private entity, a person or a company. The government does not own banks, people do. And so this is our starting point. We have our vocabulary here. And then that brings us to then the first given that they give us here. It says here that assume the required reserve ratio is 10%. This is very useful information. That means when they say required reserve ratio is 10%, that means that this is a function of demand deposits. This means 10% of, I'm going to write double D here, demand deposits must stay on site. Okay, so before I read these questions then, I'm going to just look at a bunch of information here to see what I can withdraw before I approach the questions. This is how I do multiple choice. I will cover up the answers. I'll read the question. I will predict the answer. And if my prediction's there, I usually go with it. And so I'm going to make some predictions here. So looking at this then, the reserve ratio is 10%. 10% of demand deposits must stay in site. So I see that there are $200 of demand, $2,000 of demand deposits. I know the reserve ratio is 10%. That means that 10% of 2,000 must stay on site. 10% of 2,000 is $200. So looking over here, they're telling us that all of our cash on site is $200. We just said 10% of 2,000 must stay on site. That means that this $200 is technically all required reserves. That's just good information. Because remember, reserves are broken into two pieces. We have what are called excess reserves, and we have what are called required reserves. Banking gives us the idea of reserves, which is all their cash money on site. Required reserves is the money on site that cannot be lent. Excess reserves are the bank's loanable funds. And so collectively, total reserves in a bank are a sum of their excess and required. So they only said reserves here. That means that they're not breaking it down into excess or required. We just figured out that 10% of 2,000 is 200. That means that all of the money that they have on site is technically required reserves. That means this money cannot be lent. It must stay on site. So looking at letter A here, it says, what is the dollar value of new loans that First Superior can make and explain? New loans means current loans. And they, in order to make new or current loans, you have to have what's called new money. Everything in here is old money. This is accounted for. And so does this bank have any new money? Well, here's the answer. We know that our required reserves in this scenario were already $200. And that happens to be all that they have. We know required is 200 because that's 10% of 2,000. So the question is really asking, how much in excess reserves does this bank currently have? Remember, excess reserves are a fancy way of saying loanable funds. This bank currently has $0 in excess reserves. That means that this bank can currently make $0 of new loans. Your answer for letter A is $0. And the reason is because they have no excess reserves. They have no excess reserves. So letter B. Letter B says, Mr. Smith deposits $100 of cash in a demand deposit in the bank. Calculate the maximum amount of new loans that First Superior Bank can now make. Okay, so this is, we're in business now, because now the bank can start doing some fancy stuff. Mr. Smith just deposited an additional $100. This is what we call new money. The bank can lend out of this, but before they lend, they have to withhold 10%. See, the reserve ratio is 10%. And if the reserve ratio is 10%, this is telling us that we always have to hold 10% on site of all money at all times. So going back over here to this deposit, Smith deposits $100. The question is asking, how much in new loans can this bank make? Okay, so of the new money, how much can we make in new loans? Remember, 10% has to be held on site. That means of the 10%, the required reserve is $10. That means then that the excess, which is the remainder or loanable amount out of the new money, is $90. It's $90 because 10 was that they required, 100 minus 10 is 90. That is what we call the excess reserves. So letter B says, calculate the maximum amount of new loans that this bank can make. The answer is $90. So now letter C says, as a result of Mr. Smith's $100 cash deposit, calculate the maximum change over time in the entire banking system. Now, you know that this means when they say in the banking system that we are calculating with a multiplier. So remember, change in the money supply equals the value of the bond times the money multiplier, or change in the money supply is going to equal the excess reserve times the money multiplier. We use this formula when we're dealing with the Fed buying or selling a bond. We use this multiplier when we're dealing with a deposit. And now you'll need to memorize this. This is the AP exam standard operating procedure that you have to know these formulas. They do not give you a formula sheet or calculator. Now, looking at our problem, let's find our money multiplier first. The money multiplier is a function of the reserve ratio. The required reserve ratio is 10%, so the money multiplier equals 1 divided by that ratio. That means that it's 1 divided by 10% because the ratio is 10%. Now, you can't do that math. You have to convert it to a decimal. That means it's going to be 1 divided by 0.1. 1 divided by 0.1 is the same thing as saying how many times does 10 cents go into a dollar? The answer is 10. So our multiplier for this entire problem is 10. So in order to find the loans or the demand deposits for this problem, we're using this multiplier. We're using this multiplier because this problem is all about a deposit. Mr. Smith deposited money. This was not a Fed bond purchase. It would literally say the Fed purchases bonds. It doesn't say that, so we're using this formula. So for the loans, all we have to do is pop this in. This is our excess reserve times our money multiplier. This equals 90, because that's what we found our excess reserve to be, times 10 for a grand total of $900. This bank can make new loans of $900 over time in the system. That's how the money multiplier works. Remember our process of lent, spent, saved, lent, spent, saved, lent, spent, saved. The money circles through the economy. It gets lent, somebody spends it, ends up back in a restaurant. Or a bank, I meant to say. Somebody spends it at a restaurant, it ends up at a bank. The bank then lends the money again. Now, every time the bank lends money, remember, they have to hold a little bit back in the form of that reserve ratio. So 90 got lent the first time, but the second time when 90 ends up in a bank, 10%'s got to be held at that new bank. That means there's only $81 to lend. And so 90 became 81, and it cycles through the economy fast. And we use the multiplier to get to the end results. We don't have to go through all the tedious math of finding this because of 90 plus 81, etc. And it would go through dozens of times until it became 90. Demand deposits, remember, demand deposits mean checking accounts. We learned that several times, and we're reminding again. All of this money we assume is going to get, it's possible all of this money gets saved in checking accounts. And so demand deposits then for this problem are going to be a sum of all the loans, which is 900, plus the original deposit. Remember, Mr. Smith deposited $100 of cash into the demand deposit. That's a checking account. So plus that 100, this equals $1,000. Now, when we're looking at letter D, it says that as a result of Mr. Smith's $100 cash deposit, calculate the maximum change over time in the money supply again. So change in the money supply again. So this is change in money supply equals, and then here we're using either one of these two formulas again. And in this case, we said it's got to be this formula because this is a deposit question. We know this is a deposit question because Mr. Smith deposited. And in this question, it actually says as a result of the deposit, calculate the maximum change in the money supply. So the change in the money supply for letter D is going to equal the excess reserve times the money multiplier. And in this case, then, that means it's 90 times that money multiplier of 10. Remember, the money multiplier we calculated a minute ago. Money multiplier equals 1 divided by the ratio. That was in this problem, 10%. Calculate it, 1 divided by 0.1, that's 10. And so that means that your answer for letter D is $900 again. Notice this answer and this answer are the same. That's totally feasible and totally possible. A lot of students freak out when that happens. They say, two answers can't be the same. I assure you they can. In this case, they are. Finally, looking at the last question here, it says, provide one reason why the actual change in money supply can be smaller than the maximum change you identified in D. Well, the maximum change that we identified in D is $900. So the question is saying, how could it end up smaller than 900? Now, we covered this 2 times yesterday. The first reason is the bank can't lend the money, can't lend it. Or the bank won't lend it. That could happen. The bank can't lend it because they can't find a customer. In other words, the number of times it gets lent, spent, saved is less. Or maybe the bank won't lend it. Maybe the bank keeps a couple hundred extra on site because they have a lot of customers and they need to have enough money for what is called daily transaction demand. Banks have to have enough money for what is called daily transaction demand. And what that means is if a customer comes into the bank and wants money, they have to have money to give to their customers. A lot of banks will always keep extra money because of what is called daily transaction demand. The other reason that this could happen is because maybe people don't spend it. Maybe they keep the $100 and they put it into a cookie jar, like grandma. Or maybe they're like the Gallaghers and they keep all their money in the squirrel fund, which was a big Crisco bin that they kept all their cash in. So your answer for letter E is either, it's because it says identify one reason, it's either banks can't lend it, banks won't lend it because of what's called daily transaction demand. Or you could say people don't spend it and hold as cash. And there's nothing wrong with that. People do this all the time. People like having cash. If you're worried about the zombie apocalypse, you might want to have a couple hundred or maybe a couple $1,000s sitting around because in the beginning of the zombie apocalypse, there's going to be people that still value the money even though the world is ending. And so you could buy gasoline, for example, if you're trying to get away, that sort of thing. So these are the answers to letter E. And ladies and gentlemen, this was a 2016 question from the Macro AP Econ exam.